Hello everyone, my name is Ethan Pisano, and I'm here today with my team comprised of Agent Ornelas, Maximilian Stark, and Alan Sting. I'm the mechanical member of my team, Agent's our electrical member, Alan's our controls member, and Max is our experimental member that worked on different parts within the verification task. To start us off, I have the chassis design and some of our components in place. As you can tell, the overall height is around 16.2 inches, and if we look closely enough, uh, the entire body fits within the 12-inch diameter boundary that was set. Along with that are the components, the Ackerman steering gear with the servo, the wheels, the general chassis, and the tire up top, and a crankshaft, and a solenoid. The electrical components would be within the tray up in the top portion.
Hello. I am Adrian Arnella, the electrical person on the Windows 6 team, and here you can see our wiring diagram. This is how we wired everything up. It's very similar to the one that's provided on campus, but we had our own little modifications to more closely reflect our breadboard. Here on the Arduino serial monitor, you can see that we're getting our magnometer, solenoid state, read state, and our time coming from our circuit. And you can see our circuit built entirely right here. I would show you in a better angle, but it's currently wired to my desktop PC, so I can't lift it up further than this. But here you can see that the server is functioning, solenoid, you can hear it clicking, and everything is here. Read sensors here, everything is wired. Thank you. Stop share.
Hey guys, this is group 704 for controls. Part of our assignment was to basically run the simulation and come up with a bar graph. So here's my bar graph. It is a little bit underwhelming because there's no difference between the hybrid and closed loop. This is because the way I changed the values to play around with them, there wasn't much deviation in the way I changed the numbers. It was always by like a factor of 1. So for the next test, I would just use like a bigger arrangement of numbers to see where each fails, and then this bar graph will become more accurate. So our pseudocode, we chose to basically use closed loop, and there's 4 main steps. Basically, we want to do some math to chart a course to the waypoints, and then we want to convert that to basically directions that the servo can follow, and then we want to do a feedback loop to see that if we're on the same course, and then if we reach the waypoint, you repeat everything again until you reach the next waypoint. Thank you.
This graph shows the t-test and p-values of the data that the controls member of the team gave me. Higher values of the t-value, also called t-score, indicate that a large difference exists between the two sample sets. The smaller the t-value, the more similarity between the two sample sets. A large t-score indicates that the groups are different, and the small t-score indicates that the groups are similar. Consequently, a p-value from a t-test is the probability that the results from your sample data occurred by chance. P-values from 0 to 100% are usually written as a decimal, and p-value lower than 5% is usually statistically sound. In this case, the p-value is incredibly low and way below 5%, so, and even at some point the exact same, because there is no difference between these two data sets. So we can safely assume that the data presented is accurate and not up to chance. Now, in order to measure the robot impulse or the change momentum response through the Arduino in a closed loop system, when the robot changes speed, the linear velocity of the wheels would change accordingly. This correlates to a change in angular velocity of the wheels. The change in rotation is measured using the DC motor using back EMF, which would be these formulas, where it would look something like this, where we can measure the voltage that is relayed into the closing loop, controlling the velocity, and thereby taking into account what the velocity is and what velocity we want. And depending on the desired velocity, the actual velocity will either increase or decrease until the desired velocity is reached.